Alrighty, let's figure things out. This is a key. So we've got special right triangles and right triangle trig. So for special right triangles, there are basically two types of triangles, and by basically I mean there are. So we have, where do I want to put them? I'm going to actually move this on up. I'm going to put them down here. So we have one type of triangle, which is a 30, 60, 90 triangle. So a lot of times we'll build it like this. We've got 30 here, 60 here, smiley here, two smileys here, and smiley root 3. Again, you could use variables. We use smileys. Well, I use smileys because I don't want to use like x or y, because what if there's an x or y in the problem, like there is here? So your first job is identify the piece you have. This piece here is opposite the right angle. Opposite the right angle is the 2 smiley. So that means 2 root 3 is equal to 2 smiling. And hopefully you can say, wait, if 2 smiley is 2 root 3, that means 1 smiley is just root 3. So opposite the 30 is the square root of 3. And then the last piece is smiley root 3. And that would be root 3 times root 3, because smiley is root 3. 3 times 3 is 9, so that's the square root of 9, which is 3. So that means x is 3. You could use the Pythagorean theorem if this is helpful to you. You could use the Pythagorean theorem to verify that you are correct. You could do 3 squared plus the square root of 3 squared equals 2 square root of 3 squared. And you can either do it algebraically kind of in your brains, or you can use a calculator, and you'll see that those are the same. The left side will turn into 9 plus 3, which is 12. And then the right side will turn into 4 times 3, which is also 12. The other special right triangle that we have is a 45, 45, 90 triangle. 45, 45. We write that as smiley, smiley. I don't really have room there, but that's a smiley. And then smiley root 2. So here, that is smiley root 2. So that's equal to 4. So solve for smiley. So to solve for smiley, let's divide by root 2. So that's 4 over root 2. And you can leave it like that. So right there and right there, those are both 4 over root 2. On standardized tests and that sort of thing, you may have to do something called rationalizing the denominator, which means we're going to multiply by the square root of 2. So that's 4 times the square root of 2 on top. And then the square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is 2. And then 4 divided by 2 is 2 root 2. So another way you could write that is 2 root 2. If you put that in your calculator and you put that in your calculator, you'll see that those are the same number. So keep in mind here, for these special right triangles, we have two different choices. We have a 30, 60, 90 triangle, or we have a 45, 45, 90 triangle. Be sure you are clear which one is which. Alright, this next problem, we got Bobbert was trying to measure the height of a tree in their yard, but realized they forgot their super long ruler at the supermarket. Oh no. Bobbert measured the length of the tree's shadow on the ground as 42 feet long. So the shadow is 42. Also measured the angle of elevation of the sun. So that's like this, because if we have the tree here and the sun's somewhere over there, then the shadow is going to be here, and your angle of elevation to the sun is 78 degrees. Sorry, 78 degrees. And then, assuming the tree makes a 90-degree angle, that's where I got the 90 from, we want to find the height of the tree, so that's right here. Well, this looks like right triangle trig, so let's go ahead and write down the thing we need. So, it looks like an A. Fix that, Mr. Butterworth. Come on now. So, I forgot how to write. I'm sorry, friends. And then Toa. There we go. We don't have the hypotenuse, so both those are gone, so it better be tangent. And the tangent, into the tangent, you put the angle, so the tangent of 78 is going to be the opposite over the adjacent. Opposite, pew! That's the opposite over the adjacent. To solve this one, all we have to do is multiply both sides by 42. Hey, I tried to change colors. It didn't work. 42. There we go. Multiply by 42. Multiply by 42. So x is 42 times the tangent of 78. I'm going to go ahead and use my fancy Desmos scientific calculator. 42 tangent of 78, and I get 197, I'll call it 0.6 feet. So that's the height of the tree. Pretty tall tree. If you don't get the 197.6, if you get like negative 25, you are in radians, so make sure you fix the mode of your calculator. Ooh, we still got right triangle trig here, so let's go ahead and write that down again. Toa. And let's label the sides. So what I want to do is I want to say that's my angle. Here is the hypotenuse because it's opposite the right angle. Pew! That's opposite the angle we care about, so that's the opposite. And this is the adjacent. So we don't care about hypotenuse once again. So we're going to be dealing with tangent. Into the tangent, put the angle. And then we do opposite. That looks like up, but it's opposite. Over adjacent. Now, this is similar to the last problem, but notice how the x is on the denominator. So let's multiply by x to get x off the denominator. So we have x times the tangent of 19 is equal to 15. To solve for x, we need to untimes. So since we need to untimes, let's go ahead and divide. So it's going to be 15 divided by the tangent of 19. And let's go ahead and do that in my calculator. 15 divided by the tangent of 19. And I get x is 43.6. And then the last problem of this section, we have this angle here. This is the hypotenuse. This is the opposite. And this is the adjacent. I don't care about the adjacent, so anyone that has adjacent goes away, so I'm dealing with sine. Into the sine, put the angle. I don't know what the angle is. And then O, opposite over hypotenuse. And this is the part that I struggle with because we don't have the math for, but what you need to do is you need to rewrite it where, and when you have the sine, this angle is 9 over 17, or is a fraction. You write it as the inverse sine, or some of you will think of that as the sine of negative 1, or sine negative 1, or negative 1 sine, or however you're going to think about that. It's called the inverse sine, but you have that negative 1 there of the fraction. So type that into your calculator also. It's one of the buttons you can get to if you're in the Desmos one, if you press function, it's one of your choices. The inverse sine, and then you put 9 over 17. 9 over 17. And I'll call that 32 degrees. And that's it for the right triangle trig and special right triangles. Ooh, now we have area. Okay. There are formulas. So, since there are formulas, I guess I will use them, but I'm gonna do them the way I want to do them first, and then I'll show you the formula. How's that? That sounds great, Mr. Butterworth. Okay, let's do that. So how I would do this is I would say, let's think of this triangle here. The pink triangle is base times height divided by 2. And then let's think of the blue triangle. And the blue triangle is base times height. I messed up the other one, I'm sorry. Divided by 2. I wrote down the wrong height, didn't I? You should have yelled at me. Why didn't you? You may have been yelling at me. We're just not near each other. Okay, so 4.1 is the height. Sorry about that. So if I do those calculations on my calculator, 10.9 times 4.1 divided by 2 plus 4.3 times 4.1 divided by 2. I got 31.16 yards squared. Now, there is a formula if you want to use it. I don't like the formula because it doesn't make that much sense if you don't know where it comes from. It's, how do I want to think about this? Add the bases, divide by 2, multiply by the height. A number of different ways to think about it, but that's one way to do it. So if you're using that formula, that would be 10.9 plus 4.3 divided by 2 times the height, which is 4.1. Notice, if I did 4.1 times 10.9 divided by 2, If I did 4.9 times 4.3 divided by 2, that's the same thing. So you get the same answer. And then I have a little bonus piece there, which you will not be asked on your quiz. Pretend that is isosceles. So let's redraw it. If this is an isosceles triangle, if this is 4.1, if this is 4.3, that means that this piece here is 4.3. The whole thing was 10.9, so take your 10.9 and subtract the 4.3. You get 6.6. Divide that by 2. This part is 3.3, and this part is 3.3. Now, you might be asking, Mr. Butterworth, why are you doing that? I'm doing that because I need to find the length of the slanted side there. So I'm going to do the Pythagorean theorem. I'm going to do 3.3 squared plus 4.1 squared, and then I'm going to do the square root of that. So I get about 5.3 for the hypotenuse here, which is the same over here because we are isosceles. And that means that the perimeter of this thing is 5.3 plus 4.3 plus 5.3 plus 10.9. So the perimeter is 25.8, and that's in yards. We won't be asking you that specific question on the quiz, but that is how you would do it. The nice thing about that question is it forces you to review the Pythagorean theorem and what perimeter is. All right, parallelogram. So parallelogram, we just do base times height. So we just do 11.2 times 7.3. So let's put that in my calculator. 11.2 times 7.3. And I got 81.76. And that is in centimeters squared. And it says, what additional information, if any, would you need to find the perimeter of the figure? Well, I need this distance. So they could give me that distance. I suppose, based on our previous problem, they could give me that distance, and I could use the Pythagorean theorem to find it. So a couple things that I could be given. I'm sure there are others, but that's one thing that I could list. Ooh, and the last page. All right. Always exciting when you get to the last page. Find both the perimeter and area of the kite. Well, let's see. Let's look at this triangle here. Because it looks like if I can find the area of that triangle, then I'll have this triangle, and then I could find these two triangles. They're different, but I have the pieces on those, the 6 and the 8. So I'm going to use the Pythagorean theorem. I don't know what this is. So that squared plus 6 squared, leg, and then the hypotenuse is over here, equals the hypotenuse squared. If you do 21 squared, and then you subtract 6 squared from that, you get 405. So that means question mark squared is 405. So that means question mark is the square root of 405, which is not a nice number, but that's okay. So I'm going to write that as the square root of 405. So if I wanted the pink triangle, I'm going to erase that work I just did so I have space. The pink triangle is going to be base times height divided by 2. So that's 6 times square root of 405 divided by 2, which is 3 times the square root of 405. And then I also need this blue triangle. And the blue triangle is 6 times 8 divided by 2, which is 24. Now, notice that I have 2 blue triangles, so that's 48. And then I have 2 pink triangles, so that's 6 square root 405. Now, a lot of us are going to want to approximate that, so let's go ahead and do that. 48 plus 6 times the square root of 405 is 168.7. And there are no units, so I don't have to worry about that. For the perimeter, I need to find this distance here. So use the Pythagorean theorem. 6 squared is 36. 8 squared is 64. Add those together. You get 100. So this distance is 10. So that's going to be 10 plus 10 plus 21 plus 21. So that's 42, 52, 62 is what the perimeter is there. Find the area of a rhombus. Okay, I can draw a rhombus. Let me go ahead and draw a rhombus. A rhombus is like a square, but doesn't have to have right angles. One diagonal is 24. 24. And one side length is 13. So the side length there is 13. Well, what we talked about in the video is if we were to do this, that's a right angle. So if that whole diagonal is 24, that piece is 12. So really I'm dealing with this triangle. I have a leg of 12, and I have a hypotenuse of 13, and I don't know what that is. Before I continue, notice that that blue triangle and this blue triangle, and this green triangle and this green triangle and this green triangle are all the same. So I really have 4 triangles. So 4 triangles. So if I can find one, then I multiply that by 4, I'll have the total area. So I need to do the Pythagorean theorem here. 12 squared plus something squared is 13 squared. 13 squared is 169. 12 squared is 144. Subtract 144 from both sides, and you're going to get 25. So that means that the question mark is 5, because the square root of 25 is 5. So this is 5. So the area of that blue triangle, is going to be 5 times 12 divided by 2. So that's 5 times 6, which is 30. But wait, for the rhombus, don't I have 4 of those triangles? So that equals 120, and that would be the answer to the question. We did it! Yay! Let us know if you have questions, my friends.